So with that, we're going to get started. Keep us on time here. Lynn Sosnoskie is our specialty crop weed scientist over at Cornell. She's been fantastic. We're kind of get her a little bit on loan because of her expertise in the pigweeds. And many of you have seen her. Last year, she was on board. She's been traveling the state all last summer doing some pigweed ID seminars. So I'm sure everyone has probably run into her in the last year, but she does a phenomenal job, and she's going to talk to us about resistance. What do we have? She's collecting seed from all around the state with mare's tail, water hemp. So she's going to kind of talk to us what she's finding in resistance out there. And I think she's going to end up in talking about a little bit, what are some alternative weed control methods other than herbicides. So with Lynn, I see you're on board.
Yeah, thanks, Mike. And I will just share my screen. Can you see it?
It says it's coming. There she is. Okay,
great. Thanks so much. As Mike said, I'm going to talk about the current status of herbicide resistance in New York, and we do have a lot of it. And then I've got just a few slides at the end to talk about some novel, you might call it off-the-wall technology that we've been looking at or thinking about for weed management. So just to get it out of the way, the problems with weeds, obviously the yield losses that they can cause due to direct competition. This is some work that has been done by the Weed Science Society of America, their yield loss committee. And if we do everything right with the production of our major agronomic crops, but we don't engage in weed control, we're looking at the potential for 50 to 70% yield loss in our corn, soybeans, dry beans. And this holds true for cotton and rice as well. I don't have that up there because they're not New York commodities. And those equate to really significant dollars. We're looking at $722 million estimated per year that you could lose if you don't take care of weeds and dry beans. No one took care of their weeds, to up to $27 billion a year for corn. Now, with respect to weed management, herbicides are the dominant tool for managing weeds, and they're the dominant pesticide applied in many crops, including our agronomic crops as a percent of planted acres. And they're used because they work well until they don't, and that's what we're going to talk about today. So we know that herbicides are not always completely effective, and there's a lot of reasons that herbicides can fail, whether you're using the wrong product, wrong rate, improper use or lack of spray additives, antagonism, you know, the weed being too tall or too stressed, or some sort of environmental factor affecting deposition or activation. But there's also herbicide resistance, and this is the evolution of a trait where we have a change in state of our weeds from sensitive, susceptible to a herbicide, to resistant. And we can think about it in this way. We used to be able to kill this weed with this herbicide at this rate, and now we can't. And this is some work I'm going to talk about where we're looking at paraquat resistance in horseweed, the 1X rate right there in the middle. And you can see the susceptible population easily controlling it with a 1/10 X rate of paraquat, but almost up to a 4X rate, not being able to manage this origeron population. With respect to the status of herbicide resistance around the world, 509 unique cases, 164 herbicides, 266 weed species, with the United States leading the way with 123 cases. And I'm going to tell you, when I do my reporting at the end of this coming year, this is going to increase by many cases. So in New York, we haven't had a lot of herbicide resistance screening being done. Russ Hahn did all of this work in the 70s, 80s, and 90s. But we do know that there are other species by herbicide combinations that are suspected and are in the process of being confirmed right now, particularly horseweed, water hemp, and Palmer amaranth. So I'm going to talk today specifically about the horseweed, the water hemp, and our palmer amaranth screening efforts, what we're doing now, what we're going to be doing this summer, and some thoughts about management. So in 2021, the crop specialists around the state, Mike Stanyard, Mike Hunter, Eric Smith, Aaron Gabriel, got us seed from Mare's Tail, from basically the four corners in New York State. And we grew them out in the greenhouse for resistance testing. And we went and we looked at the usual suspects, the ones that we would expect to see here in New York because of their prevalence throughout the United States. The majority came from agronomic fields and roadsides, but we do have some orchard and vineyard populations. So what we saw, this graph is showing the mean percent dead plants per population. So higher is better. Higher means 100% death. We're approaching to the ability to control all of the plants. And we didn't just screen a few, we screened up to 36 plants per population. And we looked at glyphosate first rate and classic at field rates. What you can see is there's not a lot of high bars, and in some cases, no bars at all, because we didn't kill any of those plants in that population. So we do know that the majority of the horseweed populations are resistant to up to 3 herbicides. We know they're resistant to glyphosate, classic, and first rate. And this is in line with Mike Hunter's presentation that he gave yesterday, where he discussed his own observations with control with classic and first rate, which is poor for this species. Now you'll notice population 7 and 9, also population 5. We're not going to talk about that one. Population 7 and 9 were both susceptible to glyphosate. They had variable responses to the ALS inhibitors. 7 and 9 came from grapes and apples. And the growers that manage these sites reported that their horseweed weren't responding to paraquat applications. Now, we do know that paraquat resistance has been reported in horseweed mare's tail in Canada and California. But we also know that there are other factors that can affect the efficacy of this herbicide, which includes plant size, rate, GPA, and coverage, environmental factors. But what we did find in our greenhouse screening, which is ongoing, is that these two populations are resistant to paraquat. We applied up to 58 ounces per acre and didn't see much reduction in plant growth. We didn't kill them and didn't see a reduction in plant growth. If you remember that earlier slide, what we saw was where we were able to control sensitive populations at up, at 1/10 of the rate that might be listed on the label. So we're doing further work with some testing, also looking at their responses to diquat, which is similar to paraquat, and we've also sent it away for some genetic analysis for determining the mechanism of resistance. With respect to horseweed, horseweed populations across New York, appear to be resistant to glyphosate as well as the ALS inhibiting herbicides. 2 populations are resistant to paraquat, and horseweed seed is spread by wind currents, very much like dandelion seed. And this resistance is likely to move away from the site of origin. So if you get resistance, you're not going to have resistance remain in a single place. And these plants get big and the wind currents come, we're going to move that horseweed seed around. Again, we are doing final dose response studies. I showed you our preliminary data that we had with the New York populations. We've done more detailed studies with more rates. We are going to be publishing this, discussing the resistance to the ALS chemistries and glyphosate, and also documenting this new paraquat resistance. And then we'll get those out in extension articles to you all via the regional crop teams. Just going back to Mike Hunter's stuff, it's important to start clean and stay clean, and that means those burn downs ahead of planting, where pre-emergence herbicides can be used. because that's going to reduce the early season competition and associated yield loss. It's going to buy you time for your post-emergence treatments, and it's going to reduce the densities of weeds that are going to be subjected to post-emergence control, which is ultimately going to improve your success. It is a numbers game. These herbicides are not necessarily going to be 100% effective. So if you're going to be getting 99% efficacy, 95% efficacy, even 90% efficacy, that's some plants that are going to seed, and those seed are going to be problems in the next year. So if you have 100 plants and you have, say, 99% control, you've got one plant. If you have 1,000 plants, you're leaving more plants and more plants. So the greater your densities are later in the season, when you have to go with post herbicides, the more potential plants you can leave. Again, it's a numbers game. You want to reduce the pressure on those post herbicides. Now, going into the pigweeds. Pigweeds are some of the most common and troublesome weeds in North America, and this is across cropping systems. Yes, they're problematic in corn, in soybeans, in alfalfa. They're also very problematic in our specialty crop systems, such as cole crops, cucurbits, and fruiting vegetables. And you can see here, they're either ranked in the top 5, whether being common or troublesome. And 2 of those species that we're going to talk about today, water hemp and Palmer amaranth, are quickly becoming the dominant pigweed species that we are very worried about here in the northeastern United States. The southern US has been fighting Palmer amaranth for quite some time. The Midwest has been fighting water hemp, and now we're getting problems here with these 2 species in New York. So the reason we're very concerned about these is the fact that these plants, these populations, this species, they develop resistance, and they develop resistance quickly to the tools that we're using to manage them. So we have populations of water hemp and Palmer amaranth in the US that are resistant to glyphosate and ALS inhibitors and photosystem 2 inhibitors and PPO and HPPD and very long chain fatty acid inhibitors, as well as glufosinate, dicamba, and 2,4-D. And we have populations that aren't just resistant to one of these herbicides or even 2 of these herbicides. We have some populations in the US that are resistant to up to 4 or 5 of these herbicides all at the same time. With respect to the problem here in New York, Palmer amaranth is in the red figures, the red highlighted counties. Water hemp is in the yellow. We have Palmer amaranth technically in 4 counties, but I'm going to say the biggest problems that we have are in Steuben County, and this past year we identified it in Orange County. With respect to water hemp, we have it throughout New York, but I do feel, and Mike Stanyard can correct me if I'm wrong, because he probably sees it up in northwestern New York, but I feel that the problem seems to be more significant here in central New York. So we'll go into the water hemp resistance screening. So we screened the Phelps population. We have populations from around the state, but last year what we did is we tested it against our protocols against one population while we were collecting seed from the additional sites. And we looked at multiple herbicides, and again, higher bars indicate greater control, indicate more susceptibility, more sensitivity to the products. Lower bars indicate potential resistance. We looked at it at Relied 280, Enlist, and Extendamax at a quarter the rate, a half rate, 1x rate, 2x rate, 4x rate. And what we saw was, increasing control again as we increase the rate. These plants were a little bit bigger than I wanted them to be when we sprayed. And I think that's why maybe we're not even up into the 90% control. But I do feel confident that we've got sensitivity. I have sent this population away. I have a colleague out in the Midwest who has got doing extensive auxin screening for resistance. He's looking at hundreds of populations from around the US. So this seed has gone out to him to formally evaluate for enlist and XtendiMax responses, and to show where the New York population falls relative to other populations in the United States. Now, the situation is very different when we're looking at classic and first rate and Roundup PowerMax. Again, higher bars indicate more plant death, more injury, more control. Lower bars indicate resistance. And with those ALS chemistries, we're not even getting 50% reductions, in biomass. We're not even getting 50% injury at 4x rates of these herbicides. We see a bit of injury with Roundup PowerMax, but these plants grow out of it. These were 2-week ratings. We took them out further than this, and I can tell you that the Roundup PowerMax, they look sickly for a while, but they grow out of it. And the first rate in the classic, it looks like we didn't even treat them at all. So with respect to Palmer Amaranth, again, same scenario. We looked at a single population that came from around Howard, New York, while we're collecting seed from the other populations, particularly the Orange County population. And we looked at it with additional herbicides, Enlist, XtendiMax, Reflex, Rely, and Callisto. And we were able pretty much to kill the Palmer Amaranth with these chemistries. Oh, what happened? Sorry. But just because we have resistance doesn't mean that we're always going to get control. This is what I wanted to focus on. Sorry about that. This misted spot, it's supposed to be up with the water hemp. Even though it looks like we do have resistance, or we have susceptibility to like the PPO inhibiting herbicides. We looked at Palmer Amaranth with a different with Reflex. I also have some data with some PPO herbicides that are available for use in other states where we know they have resistance to them. Doesn't mean we're always going to get control if we're not spraying at the right size. This is a water hemp plant. Grower went in and sprayed Roundup a couple of times and said, I'm not killing it. And then went in with some PPO inhibitors. And by the time these plants are, a foot tall, and, you see the burn back, but we don't see the control. With respect to our Palmer Amaranth and the Roundup, the first rate and the classic, we saw a little bit more injury from these herbicides on the Palmer Amaranth, but again, we didn't see complete control. This was data that was taken at 2 weeks after treatment. We took other measurements later, and we started seeing regrowth and rebound of these plants. So we're not going to kill them with these products. So again, the preliminary data suggests that the populations that we screened of the water hemp and the Palmer Amaranth appear to be resistant to glyphosate and the ALS inhibitors. We have collected a significantly more seed. We have since run more extensive dose response curves on our original populations to just maximize our protocol. And we're going to be conducting a bigger suite of studies this summer. The seed is spread really easily on farm equipment, especially on harvesters, which you can move resistance from farm to farm and region to region. And I'll talk about that in the next slide. I also want you to know for water hemp and Palmer Amaranth, these resistance traits move via the pollen on wind currents, and you can move resistance from a resistant plant to a susceptible plant. These two species have separate male and female plants. So the males produce the pollen, that pollen is dispersed on wind currents, and it can go and it can fertilize the female plant, and you get seed development, and then those offspring carry that resistance trait. This is work that I did and others have done previously with these species. So it's not even just worrying about seed movement. We can move resistance via pollen. There is a possibility that these pigweed species can hybridize with each other or with other pigweed species, and we can move resistance traits to other pigweed species. It is probably very, very, very low, the potential or the possibility, but it is not out of the realm of possibility, because I have seen Palmer amaranth and spiny amaranth hybrids when I was in Georgia, or what were purported to be Palmer amaranth and spiny amaranth hybrids. Again, staying clean, starting clean and staying clean, and it's a numbers game. So maximize, you know, the utility of those two past programs that Mike Hunter talked about. I wanted to talk about seed movement in equipment. So this is seed that was a screening that was done on seed that was collected from water hemp that came from a combine that was purchased from the Midwest US. The seed was sent to here to Agritech. We identified it as water hemp, and then we sprayed it. We sprayed these populations. We divvied them up across these herbicides, and we looked at these herbicides because we know that there is the potential for resistance to these herbicides, and we know that these herbicides, there's the potential for resistance from the area that this combine came from. And what we weren't able to do is we weren't able to see effective control with Roundup, Impact, Callisto, Reflex, Classic, First Rate. And so where these blue bars are, these are herbicides that we know we have resistance to. We got better control with the Rely, the Ultra Blazer, the Embed, and the Extend to Maximum. And again, I think it wasn't 100% because I think the plants were a little bit big because we wanted to ID them effectively. But some of these other herbicides, we were not able to control at all. We damaged them up a little bit, but that was it. So you've got to be very thoughtful about how we're moving this seed around, particularly on our harvesters. With respect to best management practices for herbicide resistance, iwilltakeaction.com. It's a great website, and this is a PDF talking about managing herbicide resistance, everywhere from understanding the biology of the weeds, making sure your fields are clean to start, maintaining them as clean as possible. That includes after harvest and field edges, making sure you diversify your modes of action as much as possible to reduce the selection pressure, identify those herbicide escapes early, you know, and be considering adopting other control strategies where appropriate. Everyone asks me, where's the new herbicide? You know, when are we getting the new herbicide? And the thing is let's not bet the farm on it for a lot of reasons. We have not had new modes of action come out for a very long time. There's a new one right now, right? But it's only in rice. You know, so developing a new herbicide, developing a new mode of action, it is an expensive process. We're looking at about $250 million in 2008 to bring a new synthetic pesticide to market. You know, we discuss amongst ourselves at Weed Science, you know, have we maxed out the biological target sites, you know, in the plant cells? Like, how many more target sites are there that we can have herbicides going after? And then whether the consolidation of chemical companies has improved or hindered the development of products. You know, is it inhibiting development because of lack of competition, or because chemical companies have merged with seed companies? You know, could that actually spur innovation because we want to now maximize trait technology? So I want to talk about some novel tools that we're using. We're looking at electric weeders and precision sprayers right now. The electrical weeding work we've been doing with a couple of organic farms here in New York. We've got 3 farms that have electric weeders, and it's just what it says it is. There's a bar that goes out over top of the canopy. Weeds that are above the canopy come into contact with that electrified bar. The current passes through the weed and then causes the heat that's generated, causes the water in the cells to vaporize, expand, and burst. And this is just some pictures from some of our trials out in Western New York. And what we found is that we can get some fairly good success using the weed zapper annihilator. This is a commercialized product with about 61 to 84% reduction in plant biomass in some common species that we're dealing with. When we're using the weed zapper, a little less effective against those grasses for a lot of reasons, but we're seeing pretty good success with our broadleaves. There's a lot of work that's being done out in the Midwest where they do have the Palmer amaranth and the water hemp populations specifically to target Palmer amaranth and water hemp that's not controlled in season, gets above the crop to help facilitate harvest operations and reduce seed set. I've been doing some work with a precision sprayer. This precision sprayer is being used actively out in small grain systems in their fallow years in the Western US where they want to conserve water, where they don't have a lot of water and they can't be taking really big booms out and just, broadcast spraying those entire fields. So we've been looking at a vision guided sprayer and looking at both Palmer amaranth control and horseweed control. And our preliminary results are saying that our vision guided sprayer is doing just as well as our broadcast applications for both of those species. Again, this is preliminary, and we're looking at it mostly actually in tree systems, but there's a lot of work that is being done on precision spray technology in agronomic systems. Harvest weed seed control, exactly what it sounds like. These are impact mills that are attached to the combine. And what happens is the chaff and any weed seed that gets caught up in the chaff at harvest goes through these impact mills. And they're just basically ground, and then it spits that chaff out the back of the impact mill and the mechanically destroyed seed. So what you're doing is, for those weeds that are up at harvest, some of that seed is getting swept up and pulled through the combines. Well, now that seed is getting crushed. And then instead of live seed getting passed out through the back of the combine, you're now just passing out residue. Oops, sorry. And what they found is that this technology is actually can be effective for the weeds that we predominantly deal with in the United States in agronomic crops. So they've done work to look at seed retention of different species and then weed destruction using the impact mill, and finding that for a number of species, which is including lamb's quarters, velvet leaf, ragweed, pigweed species, that we can get up to 100% control of those weed seed, that we're effectively destroying that weed and we're not returning viable seed to the soil for winter burial. There's a lot of trials that are ongoing in the United States looking at that technology specifically. They're out of Australia and Canada, but look for more information in the next year or so when those trials at universities take off. And I know I'm out of time, but I can take questions I can answer the questions in the box. Thank you so much.
Thank you, Lynn. We do have one question that we can go with. There's one in the Q&A box. Asks, Lynn, how does a cell disrupting herbicide become resistant to a plant? I thought this was a contact killer only like an acid. I assume since this is happening, it's very concerning and disturbing to have this class of chemistry resistant to herbicides. Also, do you find that fields that have the most resistance are not rotated out much, like continuous corn or soybean rotation?
So with that second one, as far as the rotation, is that Yeah, you know, when we're using like the same crops and when we're using the same herbicides, even if we're rotating crops and we're using the same herbicides, we get the buildup of resistance. In Georgia, they were doing cotton, soybeans, cotton, soybeans, and they were doing Roundup Ready cotton, Roundup Ready cotton, Roundup Ready cotton, Roundup Ready soybean. That's not a rotation. So if you've got some of those same chemistries being used across crops, then yes, we see this buildup. I'm assuming that the one is with the paraquat resistance is, yeah, so we're still trying to understand the mechanism of resistance. It still comes into the plant cell and it is still acting on a biochemical process. It still has to bind to a target site. And so there are different mutations that can be associated with either that target site that could prevent binding, or sometimes those herbicides get sequestered into vacuoles before they can bind to target sites. There's a lot of different resistance mechanisms. And we don't know ours yet.
Okay. Great information. You know, not that we needed to add it to our worries this year, but definitely it's something, like you said, we got to watch out for this to try to prevent its spread, because look what it's done just in the last couple of years across this region. So thank you, Lynn, very much. And if you, maybe there's some more questions, you know, if you have questions for Lynn, please type them in the Q&A. And Lynn, if you can hang around a little bit, that would be great.
I will.
And answer those questions, it'd be phenomenal. All right, we're going to move on to our second presentation today. Actually, she's not in person. It's a pre-recorded presentation. Tracey Baute is the entomologist from the Ontario Ministry of Farms and Rural Affairs, AFRA, that we heard yesterday from actually another member of their team, Joanna Fallings. This is I asked her to speak to us, but she couldn't make it. So what we did, with her permission and the permission for the CCA board, she spoke at their meeting in December 14th, and they have graciously given us permission to use that recording from that day. And so it kind of works out really nice, because they asked me, I actually did the open introductions and things and the questions at the end. So it kind of worked out nice for us. So we're going to play that here. And it's something that we need to talk about. Obviously, the Neonic ban, it's a thing it's not occurred yet, but it's in the works. And Tracey gives us some really good ideas about what they've been doing in Canada since their ban. So here it is. Thanks, Jeanette. Good morning, everybody. It's always nice when a fellow entomologist can introduce another entomologist. You know, we are kind of a rare breed. I've never actually met Tracey in person, but I'm very familiar with her. Her work, a lot of the work she did with soybean aphid, and particularly Western bean cutworm, were kind of a lead for us here in New York. Unfortunately, they got it before us. And so she's helped us a ton over the years on those two insects. And but today, you know, we'll talk a little bit about what she's been doing recently. Tracey works for OMAFRA, which is an acronym for the Ontario Ministry for Food and Rural Affairs. So OMAFRA is a nice acronym to have with such a long name. But it comes out of the Neonic. Many are familiar with the situation with neonics here and the possible ban in New York. And this is something Canada has already gone through. And Tracey has worked with those producers and industry folks up there for the past couple of years. And so we really want to, you know, learn about what's going on up there from their experience as we move forward to a possible ban in the next couple of years. So Tracey, love to hear what's going on up there in Ontario and what have you done with the growers and the industry with the situation.
Thank you, Mike. And you're right. We're a rare breed, so it's nice when we can come together. And I really do appreciate the invite. I'm going to try and give you the honest opinion, or at least dynamics that were at play, without shortly losing my job. But really, I come with this with a very unique perspective, because I've been in this position for almost 22 years now. And you're right, we've had soybean aphids, we've had Western bean cutworm, and some pretty big issues come up. But neonics were no doubt the biggest and most contentious thing I had to deal with as both the provincial specialist, but also trying to help solve the issue and see what we can do for growers, but also even the beekeepers. It really did bring walls up which is unfortunate because I think we could have done and made a lot more progress had those walls not come up. So, so I want to point out some of the learnings that we went through and perhaps some suggestions for you guys going forward. So before I have to talk about all the issue and the research we did, I do want to briefly give you an overview of the different players, in particular on the regulatory side. So we have as the federal system what's called PMRA. So they are the Pest Management Regulatory Agency, and they are responsible for registering pesticides, the active ingredients that are used on the treated seed, but not necessarily the treated seed itself. That is under the other federal body, which is the Canadian Food Inspection Agency. Although both players really were at a loss as to who steps in, other than regulating the actual actives on the seed treatment. So we didn't have a lot of information to go by on usage rates, etc. On the provincial side, there's two players. There's the Ministry of Environment, or it was MOE back then. They have the authority on classifying the pesticides here in Ontario and including permits and licensing, but they also monitor their usage in the environment. Us at OMAFRA have some acts at play, like the Bee Act, Plant Disease Act, Weed Control Act, that essentially try and keep issues from harming the industry, but also we're responsible for delivering IPM and doing a lot of the pest work. So we all had to come together on this issue, and sometimes it worked well, sometimes it didn't, but it is what it is. So ironically, I came back from mat leave on literally the fall of 2012 to find out that there were bee kill cases going on, and pretty substantial ones at that. So, you know, prior to 2012, there were about 4 cases of acute kills at bee yards, and that was mainly in Quebec. But in the summer of 2012 and 2013, there were numerous accounts of that. And part of it was because the weather. We had a very dry spring, and planting started significantly early. As well, in March that year, we had 22-degree days for a bit. And so that triggered a lot of flowering happening in the trees and along the fields. So planting, it just aligned the perfect storm with planting and these flowering resources. We had to go and investigate, collect bees, PMRA, as well as OMAFRA, and do some residue testing. And they concluded that there was exposure from the dust generated from corn and soybean planting, and especially those 2 years. It did start to improve shortly, and I'll talk about this, but around 2014 is when PMRA required some additional measures, but also 2015 was not an ideal spring planting. It was a lot cooler, and things didn't happen as quickly. But we did start to see a drop, though, you know, were still reports, and even to this day. And this is really just the acute reports. This isn't necessarily about the systemic or chronic issues that are going on. So this is what happened, right? We were all aware. These products were starting to be registered in the early 2000s, and usage was reasonable at that point. And then it just exploded. By 2014, there was large acreage use in almost every crop, but especially the major corn and soybean acres. And, you know, here in Ontario, we estimated that there was probably about 99% of corn treated, and soybeans were at about 65%. Of course, again, usage wasn't being tracked as well, because treated seed kind of falls off the radar of who's monitoring their usage. And so this was guesstimations, but I think they were pretty fair. On top of that, we started to see these vacuum planters come into play. So we estimated about 70% of use in corn, and of course that's increased since, and about 25% in soybeans. And that kind of explained why we weren't seeing this issue play out where there were drills being still used in soybeans or in wheat, simply because it wasn't as strongly at play as the vacuum planters. So obviously some policy had to come in. So I'm going to talk about policy, and then I'm going to also go through some of the research that we did, because there was still a lot of unknown questions or unknown answers to some of the major questions that we had as to what's going on. So initially around 2014, Pierre Murray came out with recommendations. We kind of worked together as Omafra and Pierre Murray to come up with some sound solutions. And most importantly, or at least I think the one that is obviously still at play today, is the use of requiring the fluency agent. Instead of using talc, and graphite, which was seen as abrasive to the seed, and taking that treatment off of the seed, they required in vacuum planters the use of the fluency agent, which somewhat kept more of a waxy product that keeps it on the seed mark. And that's where we thought we saw some results with lower mortality in 2014. Though, again, I'll point out that it wasn't the solution entirely. Fortunately, at the same time, Ontario decided to come out with their own regulations. So this was somewhat of a joint regulation between Omafra and MECP, but MECP definitely took the lead. They made treated seed a class of pesticides called class 12 at the time, and specifically for corn and soybeans treated with neonics. They required that all vendors who were selling these products to provide a list of those products, as well as an annual seed sales, or not seed sales, sorry, active ingredient sales each year to MECP. To use the class 12s, the grower would have to be certified through an IPM program, as well as complete a pest assessment report, which I'll talk about. And those PARs were sent to Omafra. But the Minister of Environment had an aspirational target of an 80% reduction. And I will bluntly say that wasn't evidence-based, but it was a goal that they were really wanting to try and to reach. So in terms of the pest assessment methods, they required, there was two different aspects. There was an inspection of soil, which was to be conducted annually by a grower, and every third year by a professional pest advisor, a certified crop advisor, an agronomist. And they had to meet a threshold of either 1 wireworm per bait, or 1 wireworm or 2 grubs per dig. And they had to do 5 baits or digs in a 100-acre area. Second, so that gets you the wireworm and grubs component. Then there was an inspection of crops. So they required a professional pest advisor to do this if they needed, especially for seed corn maggot or corn rootworm, or even bean leaf beetle. They required to compare a good area of an untreated field with a bad area of an untreated field, and reach the threshold of 15% in corn stand loss and 30% in soybeans. And so you can imagine we had very few inspection of crop PARs come in. So if they reached those thresholds, they would gain access to seed in that 100-acre plot, and that was only valid for a year at a time. So it had to continue each year to prove need. It was also phased in. So initially, growers could get 50% the first year of seed for their usage, and then if they needed more, they had to do a PAR. Then they phased in the certification program, which I also had to help develop, and as well eventually start to phase in these professional pest advisors, because obviously we wouldn't have enough CCAs to do everyone at once, so they kind of randomly selected counties to kind of spread out the workload. In that time period, we saw at most, based on the seeds or the kilograms of active sold each year, those reports that were sent to MECP saw only about a 38% reduction based on that, which was surprising, because I do feel that there was more than that happening, and simply because we also saw a new replacement product. So the diamides came into play, which are not classified as class 12 or now class E, as I'll talk about in a moment. So they were considered less harmful to bees, though I put an asterisk there because we're still learning more, and certainly their native bees may be having some risk, or especially chronically, because these are still systemic in nature, but they are still almost equivalently toxic to aquatic invertebrates, and those play a role now in some of the restrictions that have come from the federal system. So they are reasonably equivalent replacements, I would say, with the exception of seed corn maggot needing a higher rate, or even just considering being suppression only. Since then, we had a new government come into play for the provincial government, and so amendments were made to the regulations. So we changed from a class 12 to class E to align to federal system, but also now the IPM certification program, which was expired every 5 years, is now not expiring. So they're certified once. PARs don't expire. So now if a grower has had a PAR in the past, they can still use it for any future use, but also apply it to the entire farm property, not just the 100 acres that they had before that they were limited to. And none of the reports, the PAR reports don't come to us, or the vendor sales reports don't go to MECP. And they also added a third pest assessment method. So if they met certain risks on their farm, they could also gain access. So it was meant to alleviate some of the burden that these regulations were posing. That said, in all of this, PMRA had decided to do some special assessments, reviews of the neonics, as well on the aquatic invertebrates. So on the pollinator special reviews, they found in terms of the soybean and corn seed treatments that there was already adequate measures in place. The risks were minimized that way. Other crops definitely have risks, but not corn and soybeans. Where there is, they've identified the risk to aquatics is within aquatic invertebrate risk. And so they have since announced a reduction of the rates allowed for these. So the cancellation of the high rates, which then obviously eliminates the usage of these for corn rootworm, as well as corn flea beetle and sweet corn. So it wasn't the pollinators necessarily that were taking, or PMRA wasn't making these decisions based on pollinators now. It's based on the risk to aquatics, and that will play out in the research that I talk about shortly. As well, our neighboring jurisdiction, Quebec, has also placed restrictions. So as part of their pesticide strategy, which includes other pesticide groups, they have classified neonic treated seed on corn, soybeans, wheat, barley, oats, and canola as a class 3A. Growers required to have a permit to plant those seeds, and they have to obtain an agronomic justification with a signed prescription from a certified agrologist to prove need. And they've also added a mandatory distance of these plantings from water sources. So that's kind of the boring side, or the contentious side, I guess, in terms of what's been going on. I would say, you know, there was a lot of things that could have been done better. And hopefully, if we have to do this again, things would be done a bit differently, but we'll see. One aspect that we didn't have a lot of understanding on is the real value of these seed treatments. Just saying blanketly that we need it for everything just wasn't true, and it was hard to justify. But two, what are the real routes of exposure? And so not only was I busy trying to help with keeping the policy to some reasonable level, and we implemented the IPM certification program, we also tried to address what was going on. So I was fortunate to have my colleagues at the University of Guelph Ridgetown campus, Art Shasman and Jocelyn Smith, step up and help work on some of this research. I have a list, and I'm happy to provide this after. There were 5 papers that came out of the work that we've done. Hopefully a 6th coming, but COVID. So I'm happy to provide this list. Majority of them are open access, so happy to give this to you guys to further read. But really, it came down to trying to initially determine the sources of neonic residues. So from our work, there were a few that we found. So one in particular, like other jurisdictions have found, exhausted dust directly from these vacuum planters. But also something that we didn't expect was soil dust carried over from the previous season being moved around even prior to planting and blowing onto these potential flowers and water sources. As well, that soil dust is contributing to the abrasion of the seed, and I'll talk about that as well. And then surface water, both after a rain event within the field and also what's adjacent to the field from that fugitive dust as well. And then all of this blowing onto flowering resources, especially weeds, and in particular the tree blossoms, which, you know, not as many notice or realize that pollinators go to the tree blossoms first in the spring, but they do. And unfortunately, it lines perfectly with ideal corn planting scenario. But we've all seen this scenario, right? Beautiful dry conditions to plant, but even if there's a mild wind, look at the dust being blown, and in particular over to these flowering resources, including the trees and the ditch line along here. And that's really what adds to this perfect storm of exposure. So we went about to examine this. So we had found 9 locations with a grower and a beekeeper willing to work together on this. We had 2 paired fields per grower and a bee yard within 2 kilometers or less of those 2 fields, so that we could look at all the routes of exposure as well as what was coming off of these fields during planting. All of these growers had obviously vacuum planters as well. One surprising thing that we just decided to do prior to planting was take samples on the soil. And so with a clean glove, we took and scooped the top 5 centimeters of soil. We also did soil probes. And this again was prior to planting. But we also took a gator with a vacuum and a vacuum bag, no hoppers or anything, just for it to simulate the movement through a field that a planter may do, or even tillage prior to planting. And surprisingly, the soil had, you know, about 4 parts per billion, but that fine layer of dust that gets blown around early in the spring had 74 parts per billion. And we didn't expect that. So that is telling us that there is a concentration at the very thin layer of surface dust from the previous year that is brought up to that soil surface early spring after snow melt, and is there to move and expose some of the pollinators, etc., to neonics, even more so than the parent soil itself come the springtime. So there was 13, almost 14 times higher concentrations in that surface dust than the parent soil. This is the bigger issue. So we were able to put vacuum bags for 2 rounds on each of these fields. We also collected with vertical and horizontal slides with tanglefoot to capture some of the dust. And we also had some actual air collectors. But also we were able, in another study, have a planter rigged with a deflector that we could engage and disengage and test different talc and versus fluency agent and others. So we were able to capture the dust that was coming off of these. And what we discovered is that these vacuum planters have an air intake at the bottom to bring in clean air to keep the pressure constant. And that clean air, those intakes, it's not clean air, it's picking up that soil surface dust and bringing it into the vacuum planter. And so we were actually capturing the soil dust from these fields that is contaminated with neonic and is being abrasive, and also rubbing off the product on seed. So 98% comes from the field through the intake, brushes off that active ingredient, and blows out into the environment. So it's twofold, not just the abrasive nature that talc had, but also this intake that's causing a lot of the bringing abrasive dust into the system. So now we're seeing where fields being intaken, the talc on top of that, and that is all being drifted. And so what's coming out of the planter is, hundreds of thousands of parts per million of neonic. So our work was even over 95% of the neonic that's placed on that seed and put in through the system is getting blown off and away. So very little is actually getting down into the soil as the seed itself. And yeah, there. On top of it, we observed what types of flowering resources were along these fields, and we collected those and tested them. And again, for clothianidin, an acute toxic, or the LD50, is 38 parts per neglected is the trees that, of course, play a role and are beneficial in terms of wind erosion. And they are an important flowering resource for pollinators, but they're also adding to the risk of exposure because they are even out there earlier than flowering dandelions in the spring. So they are at timed almost identical to planting. And that is in particular willows. Obviously all of the different apples and hawthorns, that family, but even oaks. We found a lot of different types of tree pollen in the beehive pollen that we collected. And this is also playing a role. There's a picture of a beehive and yard, technically. When the bee yards are very close to corn and soybean fields and aren't given their own flowering resources, they're moving out along the edge of the field. And there's water sources right here, a little puddle that a bee was drinking from, and they're venturing on these dandelions that are right beside the field. And that is a route of exposure. So we took, for the 9-week period, 1 week prior to planting and 8 weeks after, we collected any water sources, standing surface water in the field after rain event, or even along the field's edge, or if there was a culvert or tile run. And so what we were finding is pretty steady. Outside of the field, the neonics were present and stayed stable that time. But shortly after planting, especially after large rain events, there's a significant surge of standing neonics on that water, those puddles in the field, 4 weeks after planting. That again, if there's no other places for the bees to go to, they can come in and take drinks from this exposure. So on top of where they were, the routes of exposure, we also needed to better understand the value of these seed treatments. It really, growers were bringing out, or groups saying, we need it on everything. We can't grow crops without them, which wasn't necessarily a realistic approach when we really didn't have the evidence to show that. So we worked to try and find what is that, how do we quantify their value? So again, with Jocelyn Smith taking the lead, we set up for 4 years strip trials across the province with fungicide, and then a neonic fungicide seed treatment, replicated trials. And so in corn, we had 145 were planted with 129 going to harvest and using yield. And for soybeans, there were 33 using 31 of the sites. And these pretty much were in the heavier bee kill areas, although all the way up to close to Quebec as well. So in each of these fields, there would be, they had to have 3 replications of, we couldn't go untreated completely because that was just, there wasn't enough seed. But we did have 3 reps of fungicide and 3 reps of neonic seed treatments. The growers planted them. They were to select fields that they've had past issues with soil-borne pests, but they also planted these in those problem areas. And within each of these fields, before emergence, we did digs and set up baits in the fungicide strips. There would be 3 flower baits and then 3 grain baits to try and determine the wireworm pressure. And then after emergence, we would take obviously plant population, stand, vigor, and then we did a destructive sample of a meter of row at 3 or 2 adjacent areas up these strips, and looked at both below ground injury as well as above ground injury. And then of course they took it to yield. And in year 2017, some of these growers, 16 sites actually had diamides included as well as a comparison strip. So 4 years this went on. So yep, as I mentioned, we set up those baits and we got a good sense of when baits worked well and which ones didn't. I will say potato baits were not very good, but flour and grain were adequate, though we did lose a few to animals. Skunks and raccoons love these, and even deer. So we learned to put more out than we needed to hopefully have enough. And then as well, although the literature says you can bait in the fall as well, springtime really played a better role in monitoring and using baits. So we collected, even when we did the digs, we sifted through all the soil. When we did the trench work, we sifted through the soil and ID'd all the pests that we saw. And then, as mentioned, we did vigor ratings, stand counts, and determine any above ground and below ground feeding that took place. So from these sites, in the corn in particular, stand, there was no significant difference. Vigor, which is really what some growers use to say, I need, visually, I see neonics, they look better. That's true. The research indicated that. But that didn't play out in yield. So there was no difference in root injury in these locations. There was no difference in defoliation. And out of the 129 sites, that vigor rarely translated to yield increase. So in fact, for corn, there were only 10 locations that had significant yield advantage over the fungicide seed treatment. But when you look at property, the profitability, you see that we actually, when you calculate the cost of the neonics seed treatment, you need at least a 2.3 bushel acre advantage to see that gain. And that played out only in 47%. So less than half of the sites we had saw that gain to make it worthwhile. When we looked at the diamides, it even was more questionable. Out of the 16 sites that we had, there was no consistency in the results. There was no clear advantage to using the diamides over the fungicide or the neonic seed treatments. Soybeans, very similar. though I would say even the vigor effect may be a bit stronger visually. But again, no real significant difference, and there was no gain in most of these sites. So out of, I believe it was only 2 sites that actually saw a significant advantage when it comes to the soybeans. And when you look specifically at those 2 sites, yes, there was a 13 bushel acre advantage, but rarely was there any other sites that had those significant differences. So again, looking at the profitability, you needed to actually pay for the cost of the seed treatments. It was only landed on 23% of the sites that we did over these 4 years. So, so what? The reassurance of having the treatment there is just as important. But really, again, in corn, the cost of these was only recovered 47% of the time, and in soybeans, even in fewer. And taking into account the environmental concern adds to that. Why are we using it when we don't need it all the time? And I'm not saying that's always the case, but out of the hundreds of sites that we had, it played a role very, very minimally. So in these sites, none of the sites reached the threshold, the 1 per bait per wireworm or 2 grubs. There were no seed corn maggots, which I do think neonics can play a role in if we can better predict where the problem is to use them more prescriptively. But when we looked at the relationship of yield and pest presence, there was no relationship. So again, all of these sites really didn't reach a level of pest incidence that had an effect on yield to be worth using the neonics for that protection. So in summary, it's coming down, and we see this from every jurisdiction that's doing these trials. It's not IPM. Recognizing that it's baits and soil digs make it very problematic to find and determine the presence of these pests. But we are using these so prophylactically now. It's almost insurance pest management, and the cost of recovery was less than 50% in these trials. For us in Ontario, these pests were very uncommon. There's a poor relationship with insect incidence and yield loss. So those thresholds really do need to be reevaluated, that we tend to use to either prove need or at least justify needing protection. And obviously the thresholds that were used in our regulations were not a good fit. It doesn't represent the economic injury levels. And so, rates are just really not aligning to the actual pest risk. And that I think that's important. I think we need to identify where the pest risk is and align the usage to that instead. We're not alone in these results. There's been other jurisdictions, and in particular Quebec, again, same year, published their work where they did 4 years in 84 fields in Quebec. And they showed that almost 93% of the cornfields and 69% of the soybean fields had less than 1 wireworm per bait. And there was no significant difference in stand and yield between treated and untreated. And so in their study, less than 5% of the cases, the fields, needed it, just based on the fact that there's such a low actual pest presence. And we're learning. We're learning what species of wireworm are present, and not every species of wireworm is an economic pest. So, there's positives in this. We are gaining that insight, but we still need to move the bar in terms of identifying risk and being able to use these prescriptively. So I think this is a good graphic that summarizes a lot of the research that's been going on with the potential routes of exposure in association with these seed treatments and directed to corn. So, quite a lot is lost just from planting in the dust in terms of active ingredient. Again, very little is taken up by the plants. Research is showing about 2 to 3%. It is there, and as you can see, yield benefits are very minor in the general context of farm acreage. 90% of the product is actually lost through soil and water, and that exposes the aquatic invertebrates, including the plants, are starting to take up some of these products. And then really you're getting protection from those pests about 2 or 3 weeks at most. So again, we really need to use these only where we absolutely need them. So to minimize, my slide froze there for a second. Based on just even acute and sublethal exposure and the non-targets, some of the work from Penn State, the exposure of ground beetles when they feed on slugs that are taking in these neonics, that has no effect on them, but has a harm to the ground beetles, and even the aquatic contamination, which I think is going to play a greater role in a lot of other products that we use. So, we really need to do a better job of figuring out better tools in IPM so that we can use it in season when we need to. Could this happen again? Sadly, I feel it could. We worked really hard with trying to get the planter manufacturers to both recognize or allow the use of deflectors more, which the big manufacturers wouldn't. They were concerned there would be a warranty concern, which really wasn't valid. But we identified to them that intake problem at the bottom of the hoppers that brought in this dust. And they were very reluctant to make any changes. There is an opportunity to stop that flow from happening, even before it goes through the planter. And I see, if we're going to continue using vacuum planters and having treated seed, I think that's an important problem that needs to be solved. And especially if these insecticides are coming off, the fungicide is coming off too. And we see more research showing the synergistic effect that fungicide, so meaning it amplifies the toxicity of insecticides when they're together. And so should someone start looking for fungicide dust or even diamides, which they are starting to look, I don't think we've addressed the planter issue with this. And especially again, because we're still seeing a relatively high rate of usage of any of these seed treatments across the landscape instead of really using it where it's needed. And so, there is more research coming out on the native. Everyone's focused on the honeybees, which aren't native, but the bumblebees and the ground nesting bees, the solitary bees that are concerning. But even more with diamides, for example, you look at the LD50s, they're quite close to similar in terms of aquatic invertebrate risk. And we're starting to see diamides be detected in source water. So we've got to start looking again and anticipating that this could happen again. And we do need more studies to understand the risks so that we can really, truly make more sound policies that fit for everybody's needs. My key learnings from this experience: we've got to figure out a better way for IPM and address these soil pests in particular in other ways, not just solely relying on insecticides. And I say that even from a resistance management tool. But it was very hard to support grower perspectives when we didn't fully have a good grasp on where the real high risk pests are, what the risk factors in a field that puts them in that situation, where then that we could say, all right, use it there. But we also need improvements in predicting. So when it comes to something like seed corn maggot, we really do need to start using the growing degree day models that are there and see if we can adjust the planting date to put us at lower risk for when the flies are flying around and laying their eggs. But what was really problematic is, despite having regulations coming into play, it was very hard to adjust the seed industry in providing growers with fungicide-only seed options. We don't have a system now, and we get it logistically. Warehouses and seed orders are done in the fall. Everything's got to be treated still. And so you have guesswork of how much is needed out there. So you have a warehouse full of treated insecticide or insecticides treated seed. But that doesn't enable us to be flexible in season and adjust to the growers' needs based on their risk. If it's going to be a wet year, for example, or that's a very different risk than a very dry year. As well, if we really do know, okay, I'm lined up, it's going to be a perfect seed corn maggot season. Now I need my insecticide. We don't have that kind of system, even despite having regulations. And I think that's unfortunate, because that doesn't enable us to be more prescriptive when we need it in season, because you never know what next spring is going to be right now when you're making those seed orders. But we also, what was a learning experience, and this is the case even for foliar, I get everyone's back to the wall when it comes to giving data on the usages of both seed treatments and above ground foliar products. But if it's done in a way that enables privacy, it would enable policymakers to really know, one, risks of resistance to get new products registered in their place, but even understanding, whoa, these products are being used 90% of the acres. We need to see what's going on, instead of having to be reactive when this situation happens, because it's not a good place to be at when that does happen. And truly advocate where the need is. Instead of just saying blanket, we can't grow crops without these. Well, that's not true, but there are scenarios where it is. And so show that, have data, and on-farm data that can help guide policies. Because currently usage is still not in line with the actual pest risk based on all these different strip trial work that's going on. And that's really hard to stand your ground to support growers and beekeepers being very upset, in general public. I literally drove away from some meetings watching my rearview mirror with people following me in the general public, because they don't understand the use of pesticides and they don't want to see any, which is not realistic either. So you don't want to be there if you can avoid it. It's not a good, sustainable, or a good way to show sustainability in agriculture in either camp. Beekeepers alike, they have their own practices that need some significant improvements. So with that, I tried to leave time for questions, and I will try and answer them as honestly as I can, as I said, without losing my position. But I do feel for you. I know the concerns that exist with the restrictions. No one likes to be told they can't do something. But we also need to have a realistic perspective on these products, because they do have some environmental concerns that we can't completely dismiss. So with that.
Yeah, that was great, Tracey. It's a lot of good information, a lot of good local research, which is a lot of what we're trying to build up now.
Yep.
And You know, like you said, it's hard. There's a lot of different states that have this type of research down here that show very similar to what you just showed.
Yep.
In this situation. There's a couple things in chat, but something for us, you know,
Okay.
I'm not saying we're a little different, but you know, we are a dairy state.
Yeah.
We have a lot of manure.
Yep.
On these dairies, we have continuous corn, continuous manure. Our organic matters, you know, are very conducive to something like seed corn maggot. I don't see a lot of white grub and wireworm. Occasionally, I will see them. Saw them more in the sandy soils when I was out in Indiana. I don't see them as much here. I do see seed corn maggot. I was very surprised in your trials that you saw no seed corn maggot injury whatsoever. Is seed corn maggot, is that a common insect in that area?
In certain areas, yes. So, you know, again, we wanted to get a representation of what the reality is in Ontario. So we couldn't focus entirely our trials in these, like, this is a problem field that's, you know, because if we had 90% of those fields, then we would have shown unrealistic results, right? Because they're still smaller areas that have those higher risks. And we're seeing that, especially with higher use of diamides when there's, you know, suppression only. They're seeing the difference in some cases with the neonics. But I think it's also depending on the year. If it's a dry year, the crop can come up pretty quick. The injury and risk is minor compared to those slower, cooler, damp years when all of those factors, the manure, the egg laying, everything plays out to make it a good seed corn maggot situation. So yeah, I see there's probably more value and justification in using neonics with seed corn maggot. But that said, I see there still could be some improvements on monitoring. Using sticky traps, for example, to validate growing degree models to know when adult emergence is happening. So then you can time and adjust planting date so that the crop is coming up when there's less risk. There's some research going on right now on that. I'm not saying I realize the way spring is and how you just got to get the crop in the ground. And that's why the seed treatments have been so nice to have, right? But I think if we're going to reduce our risks so we don't keep lining ourselves up for these environmental issues, we got to find some better tools to add when it comes to the real risks like seed corn maggot. Maybe, I assume Allison's nematodes don't work on the maggots, but it'd be nice if there was some kind of biocontrol option that adds to it.
Yeah, so there's quite a few things in the chat here. One was, you know, have you seen, you know, the pollinator issue? I mean, have you seen them rebound? Have you seen pollinators rebound in the last couple of years since you stopped using the amount of neonics?
Yeah, in some cases, yes. This is what was also unfortunate. There are some really good beekeepers here in Ontario, and then there's some hobby beekeepers, right? And of course, varroa mite and other issues are playing a role too. And as much as there was a push for growers to have IPM certification, it would be nice to see beekeepers also be required to have some kind of certification so that they follow some standard practices. So it's easier to really hone in on when real issues are happening, because currently there's such a plethora of some who don't treat. The irony is they have to use some pesticides in their bee yards, right? Especially for varroa mites. So those factors really make it complicated to figure out, is this actually pesticide related or not? But there are some reports still happening, but not as widely as back then. That said, it's also not as toxic of an environment in terms of really beekeepers not wanting to see these products used at all. I think we're at a more reasonable level right now, so there's not as much pointing fingers currently. But you know, it takes 1 year of bad overwintering and on top of potential exposures. And I will say again, water source, we're detecting it in water sources. still neonics and also diamides. That may not necessarily be acute, but it could be having chronic implications, like the health of the colony. And you may not see bee kills in front of the yards, but you may see reduction in production and just overall health.
Okay. Another one here. How do you ensure you've adequately designed protocols to pick up the highly variable, all or nothing nature of seed corn maggot?
Yeah, I'm not saying we have at all. I do feel you would be setting ourselves up well if we did have those tools, good prediction tools, and somewhat more flexible system to enable us to use these where we need them, but also use other tools when we don't, because we don't have that we still don't have that in place, even with all these regulations coming in different jurisdictions. Those aspects are not necessarily there yet. So we have to catch up. We would do ourselves a big benefit in predicting it better, as well as I mentioned, being able to be flexible during the spring as to when they need the product, when they don't, and having access to non-treated or fungicide only when that is available.
Question from me: have you seen? I mean, has there been an acceptance of the diamides at all? And if not, are you seeing an increase in things like capture at planting in the seed furrow or back to seed insecticides?
Yeah. So great question. So diamides, yes. Sadly, we almost shifted from what we really need is a social researcher that has an understanding of how to help change behavior when it's appropriate, because diamides now are just treated on everything, and we're not tracking that usage, right? It's again insurance. I wouldn't say there are growers that have learned doing these on trial farms. They realize I don't need it, and they've moved away. But here we've lost a lot of access to some of the soil applied stuff, and in particular, we're going to lose Cooperative and others. And so few planters still have insecticide boxes that they're not using it. That said, we just recently had a new product registered for wireworms, mainly focused on potatoes, but I see those who truly do have a wireworm issue may be moving towards that. Again, though, soil applied. So yeah, we don't have a lot of other in field, in soil or seed treatment products other than diamides to turn to right now, which is unfortunate because again, set aside the risks that they pose to pollinators and aquatics. What about resistance? We're lining ourselves up when we're solely relying on certain actives to potentially see resistance come into play.
Yeah, and that number that you put out there, that 2 to 3% is all that's getting actually into the plants.
Yeah.
I guess that's a little scary.
It is scary
when it comes to control.
Yeah.
Are diamides taken up any differently? I mean, are there a higher percentage of diamides?
Same mechanism. Yeah, same little less water soluble, some more, but same process. And so you're really getting only protection for the first 2 or 3 weeks. And then the rest is dissipated into the environment instead. Yeah.
Is there any other current research continuing on the seed treatment?
More so, especially on pollinators, right? And understanding native in particular. So I could foresee us seeing more research coming out on the risks that these pose. In terms of on-farm trials for the value, I don't see us repeating that currently because we just have shown that, in general, very low incidence. And so now we just really need to try and improve prediction of when it is a problem and also help move that behavior towards focusing on their use when they need it.
Okay. Is there any other questions? I don't see anything. One more here. Does application get better uptake than seed treatment? Is this a statement on seed treatment usefulness overall?
Do they mean that like the binding of the active on the seed? Is that the question?
Does application get better uptake than seed treatment? I'm not sure what that means. Does she means foliar application or?
Yeah, again, these are all systemic. So even foliar, and I stuck to the seed treatment risk. There was identified risks to pollinators from foliar use here by the federal government, where they are starting to restrict use on some crops because of that. That's the problem. These products were used ideally because they're systemic. So the pest can take a bite of the plant and get exposed to it. But at the same time, that means it's being brought into the pollen and the nectar, and as well moving into the soil because it's not staying in the plant for long. And so, it's a double-edged sword. It's the ideal mechanism to expose the pest, but we're also exposing other things too.
I guess the major question is, Tracey, how do we improve that 2 to 3% to get taken up in the plant? So there's our stopgap right there. There it is, and that's unless it's more towards traits and RNAi and other features, I don't necessarily see how these systemic pesticides are going to do that and remain in the plant and not move out. Well, that was a fantastic presentation, Tracey. We're right at 10 o'clock. We finished perfectly.
Good. I hope it helps. Happy to take any questions offline too. Feel free to email me, and I can provide that list of research papers if you're interested too.
Tracey, thank you very much. All right, so we're back. We're back live now. Probably just thought we were going along and in person. Interesting talk from Tracey Baute. You know, a lot of this information is coming now. I think we do have a couple questions quickly here. A lot of potato growers use neonics. A lot of them think that when using in-furrow treatments that they are not harming bees. I've read that it still gets into the plant and harms the bees too. Can you clarify this? Well, I mean, she just, I think, kind of proved, you know, as neonics, even if it was seed treatment or in furrow, they're still getting off through the water and such. But if it's below ground, obviously it's not getting, you know, with the planter situation, it's not getting in that 2 to 3% that she was showing from air planters, particularly getting into the air. So, yeah, I think there's a less risk when it's below the ground like that. But it's still finding its way. That 2 to 3%, it's all that's going into plants pretty scary when the rest of it is all going out into the environment. So I would say there's still probably some exposure there, obviously. Water could be a big one, but not sure on that. Someone else asked about finger pickup planters. I have not delved into that at all, you know, in regards to what kind of exposure versus the air planter in regards to that 2 to 3% that's coming off. So that's all we had there. You guys made it to the last 30 minutes here, and that's me. All right, so I'm going to be the last presenter here, talking a little bit about some weed issues. This. All right. Okay, so I'm going to go through just some updates in wheat. Okay, so winter wheat in New York. Just kind of give you guys an update. We had a record high yield this year. 77 bushel average for us. That was up 11 bushel from the previous year. You know, 9.6 million bushels harvested this year. 125,000 acres, which in most cases is usually fairly average, but that was up 5,000 acres. from 2020. So we had more acres there, record high yield. Okay. All right. So how was it going into 2022? How did things look? I look at the NASS Northeastern Field Office reports every week that come out, and the very last one that they do is usually the very end of November. And so that was November 28th, where we saw 91% of the wheat, they say, was planted, and 85% of it was emerged. So I'm not sure I quite agree with that 85% was emerged. There was quite a bit put at the end there that obviously was not going to emerge. But they stated that 51% was in good to excellent condition. Okay, so about half of it, and I would say that's pretty accurate. 42% of those fields were poor to fair condition. Okay, so that the lower end of that I would agree with. And 7% was very poor. So to compare that from last year, in 2020, we had 74%, so roughly 3/4 of it was in that good to excellent condition, and only 25% was in that very poor to fair condition. So definitely a different year at the end for us. And I just want to kind of put some of this this up here. On emergence. So they also track, when wheat was planted, what percent of the wheat in the state is planted, and the percent wheat emergence. And we saw from Joanna's presentation yesterday that, a lot of their wheat up there gets in September. They want it in there in that late September date, ideal for us too. We always talk about when is the fly-free date. And usually that's around September 15th. And I have some guys that call me every year when is this going to be, and I'm always reluctant. That's a great date to start, but I have never seen a Hessian fly. So, but usually before September 15th, things aren't that conducive to planting anyway. Again, depends on the spring. Is it wet? What are planting conditions? So this year, if you look here, we're just up through October 3rd. Roughly, 30% of our wheat was put in the ground, in that September timeframe, we'll say. So pretty good numbers, to get in before October. In October, 34, we jumped to 85. So 50% of our wheat went in here in the month of October. And ideally, I like to, if we, depending on weather, I like to see us in, at least by the third week in October, I like to see us in at the latest, ideally mid-October. So 3/4 of our wheat was put in, I would say, in really good timing wise, to get those fall tillers and, get some good growth on there to be able to get the tillers we want. And if you looked after October, we had about 6% of the wheat that got hammered in here at the end. Really not sure what it's going to be. We had really wet conditions here the last part of October and November, obviously. And so a lot of this is probably where a lot of our poor wheat could be coming in to play. And again, here's where they show the wheat emergence through October 10th. It was the first it detected at 7%, and came up rapidly through October, and then the last little bit here in November. So winter wheat seeding report. They do this at the very end of the year. This is done the first 2 weeks of December. And they're saying they're going to estimate that we have about 130,000 acres, which was down 16% from 21 and down 13% from 20. So definitely this year, we're going to have lower acreage that's out there. So we'll just prepare for that. So if you went and look at a lot of these fields, one thing I'm going to talk about, a little bit, is weed control is going to be very important. Why? Well, I mentioned earlier, you saw the report that only 51% is in good shape, as they would claim it. And a lot of it was due because of the wet weather during our planting season this year. There's a lot of holes out there. I've had a lot of folks call me saying, man, I'm not sure I'm going to have to make a call in the spring if this is going to stay in wheat or it's going to get plowed down. We had some folks that had these big wet holes that dried up a little bit. They went back in with the drill, tried to replant those sections, and all it did was rain about 6 or so days later. We had another rain, which very, very little of that replanting was successful. So we have these fields, some, maybe half of them that aren't optimal when it comes to population. We have some holes, winter annuals, I'm sure were emerged in, already emerged in those holes. Annual grasses we'll deal with in the spring. Some of the perennial grasses, winter annual grasses are there now. Mare's tail could be there now germinated, but we also could get mare's tail to germinate in the spring too. So, I did catch a couple people that late were able to get some weed control out there with some nice days that we had, and fields that weren't too wet. But the majority, I think, we're going to have a weed issue in a lot of these low population fields. And it's maybe, and we talked about this earlier, is all that available light that's going to be coming in there. So, it's going to compete a little bit more with the wheat. That wheat's going to, not cover it as well and shade out some of these weeds and prevent them from getting any bigger. So I think, spring weed control is going to be very important this year. And I kind of review these a lot each year. And what can we do? Well, we talked about Osprey, and now that it's Osprey Extra. There may be still some Osprey out there. I'm not sure. There was last year, but Bayer has moved to the Osprey Extra, which has that thiocarbazole to that mesosulfuron. So again, there's a special local needs only for winter wheat, and it's control and suppression, mainly the rough-stalk bluegrass and sheep. And I tell you, I'm going to say the last 5 years, I've really seen a lot of rough-stalk bluegrass out there, and you can see it. It's right about time wheat is heading out. You can see this reddish orange clumps out there, which is the heads of the rough-stalk bluegrass. So I've really seen a lot of that. It's very visible at that time when it heads out, and there's a lot of it in really thick patches out there. So this is something maybe we probably should be looking a little closer at of controlling. Now, the problem is with some of these, they're always got to be done early. So emergence to jointing stage. So that can happen very quickly in some years with some heat. And, if we start getting rainfall, it's just not going to happen. So unfortunately, it has to happen really, really early. And we have to be on our ball game to get that on. As we move to the spring, think about some of our annual grass control in wheat and barley. We have the Axial XL. We have the Axial Bold from Syngenta. Foxtail and barnyard grass are the two biggest ones we're worried about. We can have some Italian ryegrass issues, cover crop wise, and volunteer oats too. But foxtails is probably where it fits in the best there. And again, like the Osprey, it's got to be put on early before that jointing stage, or you can ding that grass. Husky, we've had that special local needs for a couple of years now, and it's only for resistant mare's tail. So, both Mike and Lynn talked about the mare's tail issues. That's been around a long time for us here. But I tell you, the last 2 or 3 years, it's gotten worse here in Northwest New York. It was bad for a long time. Then for some reason, it kind of, I don't know, it settled down. I didn't see it as much. But the last couple of years, it just seems to be everywhere out there during harvest time. And, that has two active ingredients in there. And most guys are tank mixing that with Harmony Extra. Some guys are doing it in the fall. Most guys are doing it in the spring. And they are saying that it is successful. Just to make sure you have that higher rate in there. And it can be applied up to flag leaf. So it's something that can be, a little later for us if we do see some issues. And just remember, that if we do have mare's tail that is germinating in the fall, as it makes its way through winter and gets bigger and thicker, it is so much harder to kill as that stem elongates in the spring. So you've got to get it early to have any kind of a good kill on it. This came up the other day, so I wanted to add it. Storeside 2 is one of the very few insecticides we have to treat our wheat going into the bin. It also can be used as a empty bin treatment. There's some restrictions on how you can apply it. Tempo SC is our other one that can be used only for empty bin. But on Storeside 2, one of the active ingredients is chlorpyrifos methyl. And this is where I've had the questions. You know, we all know that chlorpyrifos has been banned in New York. And I think it was last January where we couldn't use it anymore. But so people are asking, can we use this? Well, this is chlorpyrifos methyl. So it's a different active ingredient. It's treated differently than just plain chlorpyrifos. So yes, Storeside 2 is still legal to use. And it's a very important, you know, for us in the wheat industry here for storage. So just wanted to make sure that everyone was aware that, you know, chlorpyrifos methyl is different than just chlorpyrifos. Gary gave some really good updates on some of the fungicides with Mirabis in there and Carumba, changing names with adding an active ingredient. So that was a great summary slide. I probably should have stole that and throw that in here with the new name of Spherix. And from what Gary said, that Carumba is still, you know, there are some supplies still out there, but that eventually will be phased out, much like the Osprey and Osprey Extra situation. The Spherix will be the new one that we'll see moving forward, maybe totally after this year. So that's kind of more of the, you know, the pest control chemical updates that I like to, you know, throw in there every year, just to make sure you guys are aware of those. So something, I do this every year in this presentation when I give it, is to talk about, you know, the National Wheat Yield Contest. And it's been going on, you know, for a couple of years. There's 4 categories, obviously, and the one we're most apt to go after, obviously, is the winter wheat section there. We do have some spring wheats, but not very many. So we're looking at winter dryland. Again, this has been going on for 5 years now. They do have the raw yield and the percentage above county average now. So we're after the raw yield. This year, you know, they had 387 entries. Usually have about 400 entries. Only 150 of those were completed to yield. And I think a lot of this, we saw this here in New York, right? Even though we had a national, a statewide record yield, but we bombed when it came to quality. And that's because probably after July 5th, it just wouldn't stop raining. Gary talked about this yesterday with the pre-harvest sprouting that occurred. Those falling numbers just plummeted for us. And I think a lot of these situations happened with that around, you know, around the area and other states in the Northeast here. So you have to be a National Association of Wheat Growers member. Everything's online. So they took everything. If folks here have ever done the National Corn Contest, everything had moved online. So you fill all the forms out online, you make copies of things, you scan them in. Everything is electronic now and digital. Nothing, no papers are sent in. It's $100 per entry if you enter by April 15th, $125. The last entry you can put in is May 16th. So I push, you know, I try to push for this every year to try to get some more New York growers involved in this. And some of the rules, the biggest one here, I think, again, it's just like one of the yield contests. You have to have a supervisor. This is a little different. This one's 1.5 acres. So for us, soybeans is 2 acres. For corn, it's 1.25 acres. So this one's 1.5. And there is a reweigh if you hit 150 bushels on there. They also, quality is a big thing. You have to submit a quality sample, and it's got to rate as class 1 or class 2, qualify for one of the winter spots. I wanted to go through, I like to show this every year, you know, what are some of, you know, this is the national winners. And you can see the numbers are much lower than last year. I think the winner last year, dryland winter wheat, was like 190, something like that. And there was a bunch of 170s, even into Michigan. But this year, you know, the winner was from Maryland. 141 was the national winter wheat dryland winner this year. That's what they call the bin buster. After that, you know, everything's pretty much here in the Northeast. First place after that was Jeffrey Crone from Michigan. And actually he was involved, you saw his name in Joanna's data from up in Michigan from the yen contest. He was I think the highest yielder in that yen contest up there at 140. Then we jumped down south of us, just in Lebanon, Pennsylvania at 140.43. Over to Ohio for third at 138. Fourth down to Kentucky at 126. And then fifth all the way out to Kansas at 125. So you look at these numbers, these are pretty reasonable for us here in New York. I know many of you can hit that in certain years. So I think we have the potential, at least this year, we could have had the potential to be on this board. And I always want to stress that to you guys that they're growing wheat. So what was the nationwide high yield winner? Well, we talked about the 190s last year in dryland. Well, this year the high winner was 192, but it was irrigated winter wheat out in Oregon. So that's still a phenomenal. It's like these, I'd love to walk through, you know, a 400 to 600 bushel cornfield. I'd love to walk through a 200 bushel wheat field and what that must look like. So maybe one of these days. So I also wanted to some other the state winners around us and what they do, that like the contest for corn, they throw everybody into a state contest and they pick the top 3 there. So you can see Michigan. We always saw Jeffrey Crone, but Dwight Bartle, you remember Dwight? Dwight spoke to us last year at Congress. I actually went and visited him this spring up there in Michigan to see what he was doing, him and his wife, Nancy. And he had some good numbers up there, 129, 123, not his best. He was a little disappointed. They were a little dry, but still some good numbers. Ohio, you know, a couple of them in the 130s. Down to Pennsylvania, winter 140, 130. So again, some pretty decent numbers out there for the season that we had. What about New York in 21? Remember last year we had our first one actually enter. It was Matt Toussaint up there in Orleans County. No final yield entries for New York this year. I think we had 5 or 6 folks that actually entered, and unfortunately, as you all know, I mean, there was probably some pretty good yields, but the quality was not there to make that class 1 or class 2, I think, and so nobody actually harvested and submitted. And so right now that 110, you know, 0.97 that Matt submitted in 20 is our top yield so far in this national wheat contest for New York. So again, still a great number, but it's still hanging out there, and Matt's still holding on to it and waiting for you guys to do better. So we have some time, and I was hoping we did. You know, talk about wheat, but this also is a soybean Congress, and I do run the soybean yield contests for the New York corn and soybean growers. That's held every year, and it's really, it's great. We just had the award ceremony the end of last month out in Syracuse, where we got to get together and actually hand out these prizes. And so I wanted to talk a little bit about this, since, you know, many of you weren't there, and just to talk about who, you know, what were the numbers, what were the winners, particularly there's 5 regions, but in our regions here in Western and the Finger Lakes. And just a little bit of soybean yields. You know, we averaged 53 bushel this year as a state. Believe it or not, that was a record high harvest for us. Up 2 bushel from last year. We had 320,000 acres harvested, and that was up 8,000 acres from 2020. So we had some great yields with some higher numbers. Across the state, I always do a slide like this to compare. Where are we? The national average, you know, just over 51. So we're over the national average. That's a great place to be. But who won it? Illinois was the soybean king this year at 64 bushel, and they were up 5 bushel from last year. So there was some lower numbers that got hurt last year. Iowa was number 2 at 62. Indiana at right around 60. They made the biggest jump of 8 bushels from last year. Ohio hanging around 56, Wisconsin 55. We were at 53. Pennsylvania was at 53. Now we were only up 2 bushel. Pennsylvania was up 7 from last year. And you guys all know I'm a PA native. I'm a Pittsburgh guy, and I always want us beaten Pennsylvania. We did last year, but this year had to settle for the tie. Michigan at 51. Minnesota was the only state down this year, down to 47, down 2, and from my understanding, it was fairly dry up in that region. And that was the cause of their reduction up there. So there was 118 entries this year. Only 47 of them got harvested. I said we got near the end, and I think we had some wet weather, and guys just went. Decided it was more important to get those soybeans in, get your wheat planted, whatever. And I totally understand that. There's 5 regions across the state we've divided it into. This year was entries from 27 different counties for the contest. So that's awesome. I think it's the highest number of counties we've had participate. So let's go through some of these winners. We'll start here in the Western region because that's where we are sitting right now in Batavia. And the way we do the soybean contests, and again, there's not a national soybean contest. This is the state contest that we put together with New York corn and soybean growers and started in 2011. And so we have really 4 maturity groups that we plant here. We have a 0, we have a 1, we have the 2, and we have some 3s. And so what we do is we pick who is the highest in each of those maturity groups. So there can be 4 winners from each region. Not every region enters a 0 or 3. 1s and 2s are pretty consistent, but 0s and 3s can be, hard to come by. So they start the group 0, Brad McCauley, Livingston County, just over 75 bushel. I'll take that all day for a group 0. Group 1, Tom Corcoran, also Livingston County at 77.37. The group 2 winner from the West region was Ryan Swede down there on the Wyoming border at 81.66. And the group 3 was John McCauley down in Livingston there at 67. So this is the only region of the 5 that actually had 4 entries. Somebody had entered in each of the 4 classes. So that's, that's nice to have. Finger Lakes region. Group 0 was Ray Dean over in Cayuga County. Again, 73.5 bushel for the group 0. That's, we're running that all day. And we have a lot of guys that are planting the group 0s and early 1s, mainly, a lot of the wheat producers, so they can get that, get those out by mid-September and get that wheat in on time. So that's, I'm seeing that more and more, these early groups. And look at the yields. Can't balk at that. The group 1 winner was, Friar Farms down there in Seneca County at 78.03. The group 2 winner was Bobby Thompson, also down in Seneca County at 82.61. And we did not have a group 3 winner. So we have the regional winners, and then we also have the state finalists. So the top 3 winners, the top winner gets an all expense paid trip for 2 to the Commodity Classic, which this year is coming up here next month, is in New Orleans. It's always the first or second week in March, so it's always nice, usually somewhere south, which is always nice to get away. So that's what the top winner, prize winner. Second place is $500, and third place is $250 prize for that one. So let's start. Third place this year in the state was Ryan Swede down in Wyoming. We saw him at 81.66. The second place winner was Mike Vecchio. He's up in Oneida County at 82.45. And our top winner in the state was our own regional Bobby Thompson down there in Interlake at 82.61. So it's always nice to have since I do the contest, to have somebody in the region that wins it. We did not win corn this year. Corn went to a grower in Montgomery County. Yeah, we still hold this trophy, and it's a big trophy. You guys know Bobby. It's his son Rob with him at the Winter Expo that was held a couple weeks ago. He gets this cup for the year. It's engraved on the side with everybody that's won it, and he gets to hold on to it and try to win it again next year and keep it in the shop. So it's always nice to have that there. There are some really other good yields across the region, and I usually throw up the top 10. We saw the top 3, but Jim Hoffman over there in Livingston County also had a great yield at 79, just got beat out in that particular category. We saw Friars, Joe Van Lee shots over there in Oneida with a good number. Andrew McElroy at 78 bushel in Wyoming. We saw Tom. Dennis Forrester's up in Jefferson County, so the north, they can grow soybeans up there. He does well every year in Jefferson County at 76.5, and Ded Fedor is also up there at 76. So it's nice to see we have some great soybeans in the region, and just want to recognize these guys with some of the time we had. I do see one. Ron Pearl asked, how do you get in on the contest? Again, it'll probably come out probably in July. New York corn and soybean growers will send that out. You can always go to their website and pick up that entry sheet for that. And you fill the sheet out and you send it to me. And all the explanations are on that. So definitely, if you have any other questions, please just call me or Colleen Klein, who's the director of New York corn and soybean growers. You can always ask her also. you know, how to get into that. But yeah, we won't see the flyer for that probably till July. And the deadline is usually around August 31st, usually after the national corn contest. We try to run it a little later than that. Okay. All right, folks, we're on time. I don't see other questions.